Welcome to section 3.5. The 5-number summary and box plots. Objective 1. Compute the 5-number summary. The 5-number summary is 5 statistics that describe a set of data. So the first number is the minimum value. The second is Q1. The third is Q2 or the median. The fourth number is Q3. And the fifth number is the maximum value. So let's now apply this to an example. So the following data represents the travel times in minutes to work for all 7 employees of a startup web development company. Determine the 5-number summary for travel times. Okay. And so to do that, we are going to utilize our calculator. All right, so first we're going to go to Stat, then we'll go to Edit, we'll press Enter, and we will then enter in all of our data values. So 23, 36, 23, 18, 5, 26, and 43. Next, we will press Stat, and we'll go over 1 to the right to go to the Calc menu, and we will select number 1 var stat, and press Enter. We will make sure our list that contains our raw data is selected in the List row. Our frequent list is empty, and we will select Calculate by pressing Enter. Now we are on the var stat screen where we can scroll all the way down and look at our 5-number summary here on the screen. So we have our minimum value of 5, Q1 is 18, our median or Q2 is 23, Q3 is 36, and our maximum value is 43. Okay, and so now we have our 5-number summary. All right, why don't you pause the video and find your 5-number summary for the set of data. Okay, hopefully you attempted this problem. So your 5-number summary for this data set would be 43, 77, 86, 94, and 100. Okay. Objective 2. Draw and interpret box plots. Now the 5-number summary can be used to create another graph called the box plot. Box plot or box and whisker plot is a graphical representation of the 5-number summary. So in drawing a box plot, we first are going to find the 5-number summary. Then we will draw a number line long enough to include the minimum and maximum data values. Then we will insert vertical lines at Q1, the median, and Q3. We will enclose these vertical lines in a box. Next, we will calculate the IQR. Then we will determine the lower and upper fences. We will draw brackets at the lower and upper fences. We'll then draw a horizontal line from Q1 to the smallest data value inside the lower fence. Then we'll draw a horizontal line from Q3 to the largest data value inside the upper fence. These horizontal lines that we've just drawn for step 7 and 8 are called the whiskers. Then we'll label any outliers with asterisks. These outliers are the data values that are less than the lower fence or greater than the upper fence. Okay. So in my example with my 7 employees at my startup web development company, I'm asked to construct a box plot based on my calculations of the travel data time. So in our previous example, we found the 5-number summary. So the first thing that I'm going to do is I'm going to create my number line such that my lowest value and my highest value are included. Next, I'm going to draw the vertical bars at Q1, at Q2 or the median, and at Q3. Okay. Then I'm going to add my whiskers for my lowest value and my highest value. So my lowest value is 5 and my highest value is 43. Then I will add brackets for my lower and upper fence. So we found a lower and upper fence in the previous section. My lower fence was -9 and my upper fence was 63. Now this example had no outliers, so I didn't need to include any asterisks. All right. Now, why don't you pause and construct a box plot for the course grades? Okay, hopefully you paused and attempted this problem. All right. This is a data set that we've looked at in the previous practice. So you have the 5-number summary. And then in the previous section for this data set, you found the lower fence and the upper fence. And we identified that 43 is an outlier for this data set. So your visual should look something like this. Okay. So you place your vertical lines at Q1, 2, and 3. Create the box. The length of the box is going to be your interquartile range. And then you'll place your lower and upper fence by these brackets. Okay. Then you would place smaller vertical lines at your smallest and largest values that are inside of your fence and connect them to your box. Those are your whiskers. And then you add an asterisk for any outliers that are contained within your data set. Okay, awesome. All right, let's do another practice. I will be walking through this with you. So, first, we are told that the following data represent the hemoglobin for 20 randomly selected cats. Okay. Note that the data values here are written in ascending order, so that's going to help us. A is asking us to compute the z-score corresponding to the hemoglobin for Blackie, who has a 7.8 G per DL, and we need to interpret these results. Okay. So first thing that we need to do is we need to find our mean and our standard deviation for this data. Okay, so let's pull out our calculator. Okay, so let's go stat, edit, and I'm going to clear this list. Let's enter in these data points. So 5.7, 7.7, 7.8, 8.7, 8.9, 9.4, 9.5, 9.6, 9.6, 9.9, 10.0, 10.3, 10.6, 10.7, 11, 11.2, 11.7, 12.9, 13, 13.4. All right. And I have 20 numbers because it says L120. So the 20th number in my list 1 is 13.4. So I know I have all 20. So now I just want to make sure that I have the numbers typed in correctly. So 13.4, 13, 12.9, 11.7, 11.2, 11, 10.7, 10.6, 10.3, 10, 9.9, 9.6, 9.6, 9.5, 9.4, 8.9, 8.7, 7.8, 7.7, and 5.7. Excellent. So now let's go stat. We just need stat. So then we go to calc and one bar stats, our list 1, yes, and calculate. Okay. So our sample here, our sample mean, X bar, is going to be 10.08. And then our standard deviation is going to be 1.89. So we'll round to 2 decimal places here. All right, so we're going to need both of those two values in order to find our z-score for Blackie. Okay. So I have my sample mean, I have my standard deviation. I can now substitute that into the sample z-score. My x is going to be 7.8, giving me a z-score of negative 1.21. So in interpreting this result, I can say that Blackie's hemoglobin measures 1.21 standard deviations below the mean. So this is not unusual because it's within 2 standard deviations. All right. So next I'm going to determine the 5-number summary. So pulling my calculator back up, if I scroll down from my 1-bar stat screen, I have my 5-number summary right here: 5.7, 9.15, 9.95, 11.1, and 13.4. Okay. And so that will be my 5-number summary, which will then allow me to do C, which is to compute the IQR. So I compute the IQR by taking Q3 and subtracting Q1. So 11.1 minus 9.15 gives me an IQR of 1.95. Okay. Next, I'm asked to determine the lower and upper fences. So I will need my Q1, my IQR, and my Q3. Substituting in those values into my formula for the lower fence, I'll get 6.225. And for the upper fence, I'll get 14.025. So those are the cutoffs for my data values to be considered an outlier or not. So if I have a value that is below 6.225, then that value would be an outlier. And if I have a value that's greater than 14.025, then that value would be considered an outlier. So next I will draw my box plot. So I'll first draw my number line, making it long enough to include all of my data values. I'll then plot my Q1, Q2, and Q3 and create a box. I'll put the brackets on my lower and upper fence. I'll then apply my whiskers, which are the lines that go to the highest value and lowest value within my fences, and then apply my outlier. And in this problem, our outlier is going to be the value 5.7 because it's less than 6.225, which is our lower fence. Okay. Awesome. Okay. All right. So now I would like for you to pause and attempt this problem. Again, you're drawing the box plot for the following sample data. Okay, hopefully you attempted this problem. So first things first, note that the data values are written in ascending order. So that will help you in determining your 5-number summary. You can find it manually or enter these values into your calculator and go 1var stats to determine your 5-number summary. From there, you will then identify your IQR, which is your interquartile range, and then you will identify your lower and upper fence, which will tell you if you have any outliers. Okay. Since our lower fence is -1 and our upper fence is 7, we have identified 2 outliers, 8 and 10, because they are greater than our upper fence of 7. Okay. Note here that we don't have any upper whisker, meaning a maximum value that is higher than our Q3 value of 4. Therefore, we only have 1 whisker on the left-hand side. Okay, awesome. So the image below shows 3 histograms and their corresponding box plots with the 5-number summary. So on the left here, you have a skewed right histogram. Under it, you have the box plot that is representative of that histogram and what it would look like. In the middle, you have your normal distribution that is symmetric, showing its related box plot that's also symmetric. Then we have our skewed left histogram and our skewed left box plot to go with it. So in identifying the shape of a distribution from a box plot or from a histogram for that matter, it is subjective. So when identifying the shape of a distribution from a graph, we need to make sure that we are supporting our statement with opinions and justifications. So talk about the interquartile range, talk about the median, talk about the mean, talk about any outliers, all of that to justify whether it's skewed right, skewed left, or symmetric. Okay, you want to take notice of the distances between the median to Q1 and Q3 and the median to the minimum and maximum values, because that will tell you a lot about your distribution and then also about what type of distribution you are observing. So let's do some box plot analysis. So for this example, we're asked to A, identify the shape of the distribution, and then B, determine the 5-number summary and assume that each number in the 5-number summary is an integer. So in our first one here, we see here that our whisker on the right-hand side is much longer than the whisker on the left-hand side. So for A, the shape of the distribution is going to be skewed right because the median is to the left of the center of the box and the right line is substantially longer than the left line. Okay. So the median, which is the vertical line in the center here, is not in the middle. It's more to the left-hand side. So it's going to be to the left of the center of the box. So that's also a reason why it is skewed right, in addition to the whisker on the right-hand side being very much longer than the left-hand side. Then our 5-number summary. All right, so we know our minimum value will be 0. Our maximum value, we would say, is 16. Our Q1 would be approximately 1, Q2 would approximately be 3, and Q3 would approximately be 6. So our 5-number summary would be 0, 1, 3, 6, and 16. All right. Next, this is our box plot. So for this one, our whiskers on both sides are approximately even, and our vertical line is right in the center of our box. So we would say that this is symmetric because the median is near the center of the box, and the horizontal lines are approximately the same length. Okay, so our 5-number summary would go -1, and then this would be 2, 5, this would be 8, and this one would be 11. So -1, 2, 5, 8, and 11. Okay. All right, for this practice, we're going to use the side-by-side box plot shown to answer the questions that follow. So we have a box plot here that's labeled X and a box plot here that's labeled Y. All right, to the nearest integer, what is the median of the variable X? So this is the variable X, and the median would be right here, this vertical line in our box, which is approximately 40. So M equals 40. To the nearest integer, what is the third quartile of variable Y? So the third quartile will be the vertical line on the right side of our box, which would approximately be 52, 53. Okay. See which variable has more dispersion in Y. Well, in looking at our box plots here for X and Y, we would say the variable Y has more dispersion, and this can be seen by the much broader range, meaning the span of the lines, and the much broader interquartile range, which is the span of the box. So both of them would be the reasonings for why our box plot variable Y is more dispersed. D, describe the shape of variable X and support your position. Well, the distribution of variable X would be considered symmetric. And this can be seen because the median is near the center of the box, and the horizontal lines on both sides of the box are approximately the same length. So this appears to be symmetric because of those reasonings. And lastly, E, describe the shape of the variable Y and support your position. So we know that the whisker on the right-hand side is much longer than the left-hand side. So we would say the distribution of the variable Y is skewed right. And this can be seen because the median is to the left of the center of the box, and the whisker, so the line on the right-hand side, is substantially longer than the line on the left-hand side. Awesome. And that concludes section 3.5.